My dear friends, welcome back to the last of the topic of differential equations. So, if you remember, so far we have already done the introduction of differential equations, the order and degree of differential equations, general solutions, particular solutions, and ways to solve or to find the solution of a differential equation. General solution of a differential equation. So in the first one that we have seen equations separable method. Equations separable method. The second one is homogeneous. So if you remember, in this method we separate the variable and then we integrate, and after that homogeneous solution we have also seen. So now there are certain equations where the variables cannot be easily separated. So in those equations what we do is we can try with the homogeneous form of solving. And if that is also not possible, then there is another method, the last one, that is called as linear differential equation. So in the exams, of course, obviously they will not be giving you which method to be doing. You'll have to identify, but of course that comes with practice only. Because the more you practice, there will come a time when you will just by looking at the question you will identify. But anyway, you practice well. Now moving on to this particular topic, that is linear differential equation. So this is like there are actually two formats. The most general form, okay, the most general form. The most general form. The most general form of differential equations is of the format dy by dx plus py is equal to q. Now what is p and what is q? Actually p and q, this can be a constant, any constant, okay, it can be constants or functions of x. Functions of x, like for example, I can give you one example, that is dy by dx plus 5y equal to maybe sine x. So this is one form of a differential equation, linear differential equation. All right, and the other format, the second format will be dx by dy plus px is equal to q. Yes, p and q again sorry, excuse me, p and q again of course will be either constants or functions of x. Okay, so if your differential equation is of this format, then let's see how do we solve it. For the first format, that is of the form dy by dx plus py equal to q, how do we get the required solution? Is first, what we will do is we will find e power integral of p into dx with respect to x, which is actually called the integrating factor. My handwriting is bad and it's going to be worse today, okay, so please bear with it because my hand is a little bit banged up, so my fingers aren't working very well, so kindly bear with it. So after we find out the integrating factor, that is if, after we find out the integrating factor, what we will do is now that we will get the required solution by this equation, that is required solution will be given by y into integrating factor will be equal to integral of q into integrating factor with respect to x plus c. Okay, for the second format, dx upon dy plus px is equal to q, same thing, you will find out the integrating factor, which will be again same, e power integral of p with respect to y, x, y only, that will change, and required solution will be given by x into integrating factor is equal to whole integral of q into integrating factor with respect to y plus c. Okay, So all this must be really confusing for you. How are we going to solve and all? But this is actually one of the most easiest according to me. Okay, the easiest ways to solve. So let's find out for ourselves how it is really easy or not. So let's move to the exercises now. Exercise 9.6. For each of the differential equations given, find the general solution. Number 1, general solution. dy by dx is equal plus 2y is equal to sine x. So this is already of the form. You're right. You know, right? Which is of the form dy by dx plus py is equal to q, where p is just 2 and q is sine x. So what we will do is first find out integrating factor, that is e power integral of px. So e power integral of 2 with respect to x. So that's e power 2x. So by now I'm sure that your differentiation is already good enough. Let me change the pen, it's really not very smooth. Then after that, simple, my required solution. The required solution will be y into integrating factor whole integral of q into integrating factor with respect to x plus c. So that's y into, what is my integrating factor? E power 2x, q, what was it? Sine x into e power 2x with respect to x plus c. So let's take out this first. Let's solve this integral part, because for those who have done integration, you will know how this particular question is done. So we'll first integrate this using integration by parts formula. So ILAT, if you remember, sine function becomes the first function, e power 2x minus whole integral of derivative of sine x integral of e power 2x. It's constant, I'll not write here, okay, see, because we already have that in the main solution. So that's going to be e power 2x divided by 2 minus cos x e power 2x divided by 2 with respect to x. So that's 1 by 2 sine x into e power 2x minus 1 by 2 integral of again cos x e power 2x with respect to x. So 1 by 2 sine x into e power 2x minus 1 by 2. I'll have to integrate this once again. Again, cos x integral of e power 2x minus derivative of cos x integral of e power 2x with respect to x, its whole integral once again. So that's going to be 1 by 2 e power 2x sin x minus 1 by 2 cos x e power 2x by 2 minus, this is minus sin x e power 2x by 2 with respect to x I. Okay, all right. So I'll just solve here. So it's going to be I equal to, let me just write down that, 1 by 2 e power 2x sin x minus 1 by 2 1 by 2 1 by 4 cos x e power 2x minus 1 by 4 e power 2x cos x, minus into minus plus, minus into minus plus, plus into minus minus, minus 1 by 2 integral of e power x e power 2x sin x with respect to x. I think that's fine. Chalo, you can note it down. So 1 by 2, 1 by 2, this is also 1 by 4. So I equal to 1 by 2 e power 2x sin x minus 1 by 4 e power 2x cos x minus, isn't this 1 by 4 into I? Because if you look at I was sin x e power 2x, so that's same, sin x e power 2x. So bring this on the other side. If I just take e power 2x by 4, then this becomes 2 sin x, 2 sin x minus cos x. Constant, let me not write again and again. In the last we will write down the constant. So that becomes 5i by 4 e power 2x 2 sin x minus cos x. 4 we can cancel, so I becomes 1 by 5 e power 2x 2 sin x minus cos x. So the solution is y into e power 2x, if you remember the solution, equal to this value we have already found out, 1 by 5 e power 2x 2 sin x minus cos x plus c. Now just putting back the value. So have to find out the solution. That's 1 by y 5 e power 2x cross multiply, that's cancels 1, so that becomes 2 sin x minus cos x plus c, this one e power 2x. Here this value and this value cancels when it comes down here, or y equal to 1 by 5 2 sin x minus cos x plus e power minus 2x into c. That's how it is done. Of course here the main problem was the integration only. The solution though it's always same only. Integration was the problem here. Okay. Alright then, let's move to the next question. Number 2. What is our question number 2? dy by dx plus 3y is equal to e power minus 2x. So again, which is of the form dy by dx plus py is equal to q, where p is equal to 3 and q equal to e power minus 2x. This will be much easier, I believe. So integrating factor, integral of e power p dx, so e power 3x. So the required solution is, I'm writing it in short, integrating factor q into integrating factor with respect to x plus c. So y into integrating factor e power 3x is equal to q is e power minus 2x into integrating factor, we got e power 3x with respect to x plus c. 2x minus 2x plus 3x, so that's 1x, simple mathematics. So y e power 3x is equal to e power x plus c. So that will be y equal to e power x by e power 3x plus c by e power 3x. So that becomes e power x minus 3x minus 2x, where this will go up, so that's x minus 3x, the exponent, minus 2x, and e power minus 3x into c. That's it. That's our solution. So obviously, yes, this is much easier. The other one, the integration only was the problem, no? So that's how it is done. It's quite simple. Okay, got it, no? We'll do one more. This is interesting. Number 3. I can tell. If I'm not mistaken, let's give it a try. But you're going to learn something from here. dy by dx plus y by x is equal to x square. So dy by dx plus 1 by x into y equal to x square. So I'll not write, okay, which is of the, in the exams do write but for now just to save time, so in which is of the form dy by dx plus py equal to q. So where I'm writing directly p equal to 1 by x, q is equal to x square. So integrating factor will be e power p dx, that's e integral of 1 by x dx, so that's e power log x. Okay, e power log x, so that's going to be x. Always remember e power log of f of x, log of a function, that's always going to be the function itself. E power log of a function will be, because these are anti to each other, no, inverse, something like that, so it will be just x only. Okay, so remember this always, e power log of a function, e power log of a function will be the function itself. So required solution will be y into integrating factor will be whole into q into integrating factor with respect to x plus c. So y into integrating factor is x, q x square, integrating factor x. So xy equal to x cube. So xy equal to x power 4 by 4 plus c. So y will be x power 4 by 4x plus c by x. So that's going to be x cube by 4 I can leave it here also. I think, yeah, this will also do. Let me just have a look at the solution. If you want, you can simplify also, no problem with that. So 9.6, question number, yeah, they have just kept it like that only. You can just keep it here also, no problem. xy into x power 4 by 4 plus c, yeah, that should do. Alright, so here this was the most important thing. Alright, so fine then, that's how it is to be done. So I'll help you out with more questions. Okay, so I'll see you in the next session then. Take care.